This video is part 2 from lesson 2 in exponent laws. So we're on page 72 of your student workbook. What we're going to be doing is we're going to be doing in this video class examples 3 to 6, and then I'll give you your homework. What you're going to see as we get especially to class example 6, is the questions are going to get much more complex. So you really just need to have a good understanding of these laws and how you would properly apply these laws. So number 3 should be a nice simple question, and pause the video, see if you could do A, B, and C. You may have a little bit of difficulty with this negative for D, but I want you to pause the video, see how much you could get of this, and then unpause the video and I'll go through the answers. Okay, so for 3A, we are doing power of a power law. So that 3 is going to apply to the 3, and then here's the power of a power. So 3 to the power of 3 times x to the power of 6, okay? Because 2 times 3 is 6. 3 to the power of 3 is 27, x to the 6. I'll show you one mistake that students make on their quizzes or exams for this. A lot of students, when they see 3x squared to the power of 3, they will give me this as an answer, 9x to the 6. And you know that that's incorrect, because what they've done is they're like they said, okay, I think the answer is going to be 3 times 3, and that's where they get the 9, but that is not correct. It's 3 to the power of 3, right? And if you check on your calculator, 3 to the power of 3 is 27. It's 3 times 3 times 3 in repeated multiplication. Okay, this is going to apply to the -2 in a bracket. I always put my negatives in a bracket. So that's going to be -2 squared, a to the 4, b to the 6. -2 squared, if you enter that in a bracket, that's -2 times -2, which is 4. A to the 4, b to the 6. Okay. C should be very simple. It's quotient law. C, there's 2 different laws that is happening, and there's a couple different ways you could answer C. At first, what I was going to do is I was going to say x to the 3 divided by x to the 2, which would be x to the 1, and then I was going to take care of these x's. You can absolutely do that, or the other thing I just realized is I could take care of my numerator, product law. That would be x to the 8. Then I'm going to take care of my denominator. X to the 2 and x to the 1 is x to the 3. Now I'm going to apply the quotient law. X to the 8 minus 3 is x to the 5. So as long as you get x to the 5 as the answer, you're doing it correctly. Okay, let's do this last guy. This 3 applies to the A. It applies to the 3 there. And then what I'm going to do with this negative is I'm going to actually write the negative in front of the 2. So I'm going to scratch that out. I'm going to put the negative in front of the 2. It applies to that -2. So what I have, because that -2 is in a bracket, I'm going to keep it in a bracket. -2 to the power of 3, a to the power of 3. The denominator for the y's is power to a power. So multiply those exponents. So 3 times 3 is 9. Then -2 to the power of 3 is -8, a to the 3 over y to the 9. And that would be your answer. Okay. Let's look at question 4. So I'm actually going to do A last. Okay, I'm going to do this guy last. And let's do B, C, and D first. For B, I'm just going to erase above. You must apply bedmass. So what bedmass states, so I'm going to write above it bedmass. Students see this 4 and they want to start going crazy, distributing this 4 everywhere. You're not going to do that. You always look and you say, can I simplify or clean up my brackets first? You do your brackets, and then when you're done your brackets, then you could go to the 4, which would be part of the exponent, okay? So let's deal with our brackets first, and let's ignore this 4 for now. Let's see what we could clean up within this bracket. So again, let's just look at the numerator. Let's look at this guy here. Let's do our coefficients. 4 times 3 is 12. Then I have y to the 3 times x to the 6. Can you apply an exponent law if we have different bases? No. So y to the 3 times x to the 6. My denominator is 6x to the 5, and that is all to the power of 4. I'm not done cleaning up my exponents, right? Or cleaning up my bracket. I could do more. 12 divided by 6 is 2. So that would be 2. And then I'm going to, is there anything I can combine that y to the 3 with? And the answer is no. So I'm going to bring down that y to the 3. And I could apply my exponent laws here. X to the 6 over x to the 5 is x to the 1. And this is all to the power of 4. Now I could apply the exponent. Now I could move to the e. So take that 4 and apply it to the 2, apply it to the 3, and apply it to the 1. 2 to the power of 4 is not 2 times 4. It's not 8. It's 2 to the power of 4, right? 2 to the power of 4. So 2 to the power of 4 is 16. Y to the 12, multiply those exponents. X to the 1 times 4 is 4. This is correct, everyone. So I want you to see that this is correct. However, I often tell students if you could rewrite this where you have like descending order of your variables. So do your x's and then your y's and then list your z's, or your a's, then b's, then c's. So how I'd actually want this written is 16 x to the 4, y to the 12. So always write your like coefficients first, then your x's, then your y's. Do your coefficients, then your a's, then your b's. Okay. Let's skip to D maybe since I have room, and then I'll erase this and we'll do C and A. Okay. This first bracket would be 5 squared, which is 25, A squared, B to the 12. That's my first bracket when I apply that at 2 in. My second bracket, there's an invisible 1 there, so that doesn't change anything. 4a squared b. Now I could multiply these two brackets together. 25 times 4, when you deal with the coefficients, you're going to get 100. Then let's do our a's next. That's going to be product law. You're going to add the exponents. 2 plus 2 is 4. Then let's do our b's last. 12, put your invisible 1 in. 12 plus 1 is b to the 13. And that's your answer. I'm going to erase this so we could do C together. So let me just erase this. Okay, for C, um, this 2 applies to the x and to the y. It does not apply to the 16. So I'm going to bring down my 16, and then I'm going to have my power to a power. So I'm going to multiply my exponents, and I'm going to get x to the 6, y to the 10, all over. That 3 applies to everything in the bracket. 2 to the 3, 2 to the power of 3 is 8, and 2 times 3 is 6. Let's simplify. Deal with your coefficients first. So 16 divided by 8 is 2. Deal with this next, your x's, because bases are the same. And what I could do, whenever I see x to the 6 over x to the 6, I just straight cancel that. 6 minus 6, what that really gives you is x to the 0, and anything to the power of 0 is 1, right? So I could write like 2 times 1, or I could just simply cancel the x to the 6 over x to the 6, and then I get y to the 10. Again, so that should be y to, maybe I'll clean that up, 2y to the 10. Okay, let's look at this last question, or which is the first one actually, A. What this 5 applies to is it applies to actually two things in the brackets. It applies to the n squared and it applies to that negative. That negative is a -1. So what I'm going to do is I'm going to rewrite this. This negative is a -1. In the bracket, I have a -1 times an n squared. That is all to the power of 5. So power to a power, and then -1 to the power of 5. So what I have is -1. Now remember this one, I'm going to write that in a bracket to the power of 5 times n. Power to a power is multiply, which is 10. This will give me, there's my -1, so let's bring that down, times, if you type that in on your calculator, -1 to the power of 5, you're going to get -1 times n to the 10. Negative times a negative gives you 1 n to the 10. And we don't have to list that in, if your coefficient is a 1, we don't have to list it. So the answer is just simply n to the 10. Okay? So again, when we see that negative in front of a variable, that's a -1. So this question leads directly into class example 5 now. Okay? So class example 5, what I really have here is -1 a to the power of 6 divided by -1 a to the 4. I'm just going to, I just need more room to write, so I'm just going to give myself more room. And then I'll bring that back after. Okay, so let's rewrite this with our division bar. So -1 a to the 6 all over -1 a, and that's all to the power of 4. Okay, this one, if you typed in your calculator -1 to the power of 6, and remember that -1 has to be in a bracket, you are just going to get 1 as your answer, and then a to the 6. Down here, if you typed in -1 in a bracket to the power of 4, you're going to get 1 as your answer, a to the power of 4. 1 divided by 1 is just 1, or it cancels. A to the 6 divided by a to the 4 is a to the 2. B, what I have here, there's no brackets, so that's -1 times a to the 6 divided by, there's a bracket here, so this would be -1 times a to the power of 4, right? So that negative is always going to be a -1, right? That negative is always going to be a -1, and that 4 applies to that -1. Okay, so in my numerator, what I'm going to have is -1 times a to the 6. In my denominator, if I punch this in correctly, that's going to be -1 to the power of 4. That's equal to 1, right? Because you got to, if it's in a bracket, it stays in a bracket. So -1 to the power of 4 is 1, and then times a to the 4. What this gives me is -1 divided by 1 is negative, and then subtract your exponents. So this answer is -a squared. Let's look at C, and let's see if you could rewrite C. So again, if I said, how would you rewrite this? That negative is -1, and then we've got a to the 7. There's no bracket there. There's a bracket here, so I've got to put the -1 in the bracket, a, and the 3 is outside of the bracket. So hopefully the first thing you could do is rewrite this. Then you say to yourself, okay, there's nothing that I could do in this numerator. That's -1 a to the 7. In my denominator, though, I have to apply that 3 to that negative 1. So that's negative 1 in a bracket to the power of 3. That answer is negative 1, and then a to the 3. Now I have negative 1 divided by negative 1, which equals 1, or I could just cancel them, right? I could just say negative 1 divided by negative 1 is canceled. And then I have my a to the 7 minus 3 for quotient law, which is a to the 4. And that's going to be your final answer. All right, let's do the last class example, which is number 6. So again, as we go through this, we're getting more and more complex. So I'm going to erase this. And I'm just going to move this out of the way. Give me more room down here. Okay, so these two would be like sort of the most complex questions that you would ever see on a quiz or exam, but you will see them. You will be expected to do this. Okay, A is the easier of the two. With A, multiply your coefficients. Negative 2 times 4 is negative 8. Let's do our exponent laws for the A's. It's going to be product law. You add your exponents and you would get a to the 7. And for your B's, oh, shoot. No, I'm sorry, everybody. I did not see that 3. I need to erase this. I did not see that 3. Let's redo this. Okay. This 3 applies to the negative 2, the A, and the B. So negative 2 to the power of 3. If you did that, you would get negative 8. Then we're doing power of power. So the A's, 2 times 3 is 6, and the B's, 3 times 3 is 9. That's what you would have for the first bracket after you distribute your 3 in. The second bracket, there's an invisible 1 there, which means basically that bracket just stays the same. So 4a to the 5, b to the 7. Now I could do what I previously started with. So now let's deal with these two brackets. So deal with your coefficients. Negative 8 times 4 is negative 32. Your a's, you're going to add, and you're going to get a to the 6 plus 5, which is 11. And your b's, you're going to add, and you're going to get 9 plus 7, which is 16. Okay, for b, there's nothing I could really do here. So let's copy that. 72 x to the 4, y to the 10 times, let's distribute that 4 in. So negative 1 to the power of 4 is going to be 1. And then we're going to have z to the 8. So that's my numerator so far. My denominator, I'm going to write out that 6. I'm going to apply that 3 into this bracket. So apply it everywhere into the bracket. 2 to the power of 3 is 8. X to the power of 3, y to the power of 2 times 3 is 6. And then there's nothing I could do here, so I'm just going to rewrite that. Z to the 8, y to the 3. Okay, from here, I'm going to clean up my numerator, and I'm going to clean up my denominator, and then I'll apply more exponent laws. So in my numerator, I have 72 times 1, which is 72. My x's, there's no x's to combine that with, so x to the 4, y to the 10, z to the 8. Let's deal with our coefficients in the denominator. So 6 times 8 is 48. Let's do our x's next. I've got x to the 3, and there's no other x's in the denominator, so I'm going to write down x to the 3. Y's, I've got y to the 6 and y to the 3. So combine those y's. 6 plus 3 is 9. And then my z's, I'm going to bring down z to the 8. Let's clean this up. 72 divided by 48. If you type that in your calculator and Math 1 fraction it, So 72 divided by 48. This will simplify into 3 over 2. Okay, so that simplifies into 3 over 2. The x's, the quotient law says to subtract the exponent, so I get x to the 1, and I'm not going to write that invisible 1. I'm just going to write x. Y is the exact same thing. 10 minus 9 is just y to the 1. And then the z's, hopefully you see, they cancel. So my final answer is 3 over 2 xy. Okay, let's look at our homework. And I think there was a couple questions in the homework I wanted to do with you. So I'm going to erase this. Okay. So what I want you to do is I want you to take a minute and I want you to keep this screen up, flip to your homework and circle this. So 5 and 6, A to D, 7, A, B, 8, A to D, 10, 11, and 12. So get that circled. And then we're going to do, we'll look at number 12 together. I'll see why I have that done. So let's look at that. Okay, so let's go to number 12 and then number 7 as well. I want you guys to star number 7. I won't solve 7 with you, but I'll show you. So let's star that one. Okay, let's look at number 12, see why that guy is starred. So for number 12, okay, let's do this one together. Okay, so it's this times this times this, but we have to apply the 2 into the bracket there and the 3 into the bracket here. So let's do that. Okay, negative 3 to the power of 2. If you do that, negative 3 to the power of 2 is going to give you 9. So I applied that negative 3 to the power of 2. Then let's do power to powers. So that's going to be m to the 4, so multiplication, and n, 3 times 2 here is 6. Okay, the next one. This 3 applies to that negative 2, and it's in a bracket, so negative 2 to the power of 3. That's going to give you negative 8. Your m's, when you multiply, you're going to get 9 m's, and you're going to get 3 n's when you distribute. Then what we have is we have 1 over 72 m squared n to the 3. Okay, so this is what we have. Now, sometimes this makes students nervous because this fraction makes them nervous. I could turn these into fractions if I really wanted to. I could just put these over 1. So what I'm going to do is I'm going to multiply 9 times negative 8 times 1, and that's going to give me my numerator. And then in my denominator, I'm going to multiply 1 times 72, right? So let's see if that makes sense. So let's take care of our numerator. So 9 times negative 8 times 1. I'm multiplying all the coefficients in my numerator. And 9 times negative 8 times 1 is 72. Negative 72, sorry, negative 72. Then let's deal with our numerator, our exponents. So m to the 4 times m to the 9. Add those exponents together, and 4 plus 9 gives you m to the 13. Let's deal with our n's on top. N to the 6 times n to the 3 is going to give you n to the 9. Now we have to deal with our denominator. I've got, for my coefficients, 1 times 72, which just gives me 72. And then my letters are just m squared, n to the 3. Okay? Now let's simplify that fraction. Negative 72 over 72 is negative 1. subtract your exponents for your m's because it's quotient law, and you'd get m to the 11. And from here, we would get n to the 9 minus 3 is 6. You could leave your answer as this. The book will often do this, though. They won't write that -1. They will write the negative, m to the 11, n to the 6. So this and this are the same thing, and you get full marks. Oh, sorry, that's actually not the answer. No. So what it says is when you multiply all this together, it could be simplified into this form, a m to the b, n to the c. The value of a plus b plus c is, okay, so what I have to actually do is I have to figure out what a, b, and c are. So let's figure out what a is. A is in front of the m, so a is equal to -1. The b is the exponent on the m, b is 11, and the c is the exponent on the n, the c is 6. When you add a plus b plus c, you're going to get -1 plus b is 11 plus 6. -1 plus 11 is 10. 10 plus 6 is 16. Okay. The one thing I wanted to just mention for question number 7. So star question number 7. This is definitely going to be a challenge question, and this is what we call a standard of excellence. So you will see this type one, at least one of these on a quiz or exam, and this just separates sort of like the top students of the class will get these ones. What I recommend when you're doing number 7 is on the Google Classroom. So I'm just going to go to our Google Classroom. Remember under the classwork tab, you have the workbook solutions. So when you're doing this homework, I definitely recommend opening this workbook solutions. And it might take a while to open there. So what I'm going to do is I'm just going to find it on my memory stick. Okay, so here it is for you guys. If you scroll to number 7, so if I scroll down to page 74, okay, it's going to be, I'll go to my other document because I'll probably be able to get there faster. So here, there's exponents lesson 1. I'm just going to go to exponents lesson 2. Okay, so when you're doing the homework, especially when you get to number 7, I would have these solutions in front of you just so you could sort of see what they've done, right? So I could see here clearly that they dealt with the numerator. So they did BEDMAS, right? They did the numerator, 2 times 1 is 2, and then they added those exponents. And then they wrote down the denominator. Then they applied they simplified this. This simplified would give you this. And then they applied the exponent here to get this final answer. Actually, one thing I should show you, you would know that that 1 to the power of 3 is 1 and 2 to the power of 3 is 8. That's how they're getting that. Again, for this one, they took care of the numerator to get this. They wrote down the denominator. They then simplified within the bracket to get this. And then this is their final answer. For C, take care of the bracket first, right? Take care of the bracket first. Simplify the bracket. So k to the 5 divided by k is k to the 4. And then you could apply your 2. This one, simplify this bracket and then just keep simplifying. And then at the end, multiply both brackets together.